Yo, what's going on, y'all? We are going to solve some radicals today. That's pretty freaking radical, if you ask me. So here are some examples. Take a look at this first one. This one's a vanilla example. You just have to do your inverse operations, nothing special. So let's go ahead and do that. Divide both sides by 2, and you get the cube root of x minus 1 is equal to 3. And now, to get rid of this cube root, you just have to cube both sides. So we'll have x minus 1 is equal to 3 cubed is 20, that's not a 2, 27. You add 1 to both sides and you get x is equal to 28. So what you can actually do whenever you do solving questions like this, you can actually check your work yourself. You don't have to wait for me to check it. You can actually check your work yourself by plugging this into your original equation. So 2 times the cube root of 28 minus 1. And we're going to see if this is equal to 6 or not. So let's go ahead and do that. Well, the cube root of 28 minus 1 is 27. And that is equal to 3. 2 times 3 is equal to 6, so you know you got the right answer. So let's take a look at this one here. Let's just try doing the same thing. So I'm going to subtract 2 on both sides. I get negative 2. And now I need to get rid of this 1/2 here, so I'm going to square both sides. So I get x is equal to 4. So let's go ahead and do the same thing. Alright, so we need to plug this in. So we'll get, let's see, 4 to the 1/2 plus 2. Is this equal to 0? Square root of 4, that's 2, plus 2, that's 4. And this is not equal to 0, so this does not work out. This is extraneous. So the answer is actually no solution. Okay, so checking your work, obviously, you can check your work if you want, but sometimes you will have extraneous solutions. And the times where you will have extraneous solutions is whenever you square, when you square a negative, or you square an x. You don't necessarily always have an extraneous solution, but you need to check your answers if you do one of these things. You need to check your answers for extraneous solutions in these two situations. Alright, so let's do some more examples. Alright, this first one is kind of another level 2 vanilla question, so let's go ahead and do that. So we're going to multiply by 2 on both sides. And now, what I'm actually going to do is I'm going to raise everything to the 5th power first to get rid of this 1/5 here. So I'm going to have z minus 4 squared equals 2 to the 5th is 32. And now I'm going to square root both sides. So I'm going to get z minus 4 is equal to plus minus 32, or the square root of 32. And you add 4. So you get 4 plus the square root of 32. And let's go ahead and simplify 32. So let's do 16 and 2. 16 is 4 times 4. So I can do z is equal to 4 plus or minus 4 root 2. And there is my answer. So whenever you have multiple square roots, like this, multiple roots, you want to get one on either side of the equal sign. So I'm going to add 3x minus 2. So I get x minus 1 is equal to 3x minus 2, and there's a square root on both sides. So now if you square both sides, check out what happens. So I square this side, and I just end up with x minus 1. The square and the square root cancel out. And here, 3x minus 2, because the square and the square root cancel out. So now you just solve for x. It's pretty crazy. So you just get 2x equals 1, so x is equal to 1/2. And if you plug this in, you should see that sorry about that. You should see that it's actually kind of interesting. So you get 1/2 minus 1 minus 3/2 minus 2 equals 0. So actually, this is actually a negative 1/2 minus square root of negative 1/2, which even though these are both imaginary numbers, you can subtract those and you still get 0. So this is actually true. Alright, so let's move on to the last example here. So here's the last example. It's whenever you have 2 roots, 2 square roots, or 2 cube roots or whatever, But you also have, it's not just those things. So right now we have 1 plus a root is equal to another root. what you're going to do is you're going to get the roots on the other side of the equal sign. So we already have that. And now we need to square both sides. So take a look at what happens. If I square this left side, I actually need to FOIL it. So, you know, it would be 1 plus this, and then times it again. So if you FOIL this, you're going to end up getting 1. 1 times 1 is 1. And then plus 2 times the square root of x minus 1. And then plus this squared. So that's going to be x minus 1. And then if I square the right side, I'm going to get x plus 4. So take a look. This 1 and this one, these make 0. I can subtract an x on both sides. So I'm just left with 2 root x minus 1 is equal to 4. If I divide by 2 on both sides, I get 2, square both sides. So x is equal to 5. And if you check your work, let's go ahead and do that. Why not? Get 5 minus 1 here. 5 plus 4. If you check your work, this should work out. So 1 plus the square root of 4 is 2 is equal to the square root of 9 equals 3. And this is true. All right, I know it talked really fast, but that's going to be it for this video, and I'll see you in the next one.